Okay, so we are in week 8, and we already talked about stacks and queues and linked lists, and today we're going to be talking about circular lists and operator overloading. Okay, so overloading operators is not something that is, well, it's something unique for C and C++. It's not something that Java has. It's not that you can't do similar things with Java. It's just that, they simplify the language basically. And I think I might have some examples in here on how you would do it with overloading operators in Java, well, the equivalent of. So first of all, let me start with operator overloading. And what's operator overloading? Well, basically, you're going to redefine the meaning of these different operators, like the addition, the subtraction, the multiplication, the division, equal, right? The equal sign. So these operators can be used for the basic data types in C++, right? If you want to add 5 plus 5, you can add them. Right? If you want to divide two numbers, if you want to compare a string to a string or whatever, you can do those things with data types that are built into the language and are part of the language. But since we've been creating our own data structures, we've been creating our own whatever we want at this point, we want to be able to also compare, let's say, an apple to apple, right? And then if you try to say apple 1 equal apple 2, C++ is going to tell you, what? Like, how am I supposed to compare these things? Well, that's the purpose of these, operator overloading. So, I have a pretty little picture in there for you with a program that you're going to have to type up. And so what I came up with is a class called distance, right? Bless you. And in that class called distance, I just have one variable, meter, right? We're going to have a constructor which makes the meter equal to some value, and then let's go look at the main. So first of all, I go and create a bunch of distance objects, right? D1, D2, D3, D4. Okay, I do the bool alpha. You guys remember what the bool alpha does? Makes the zeros and ones true or false, right? Otherwise, true is going to be 1, 0 is going to be false. Okay? In here, and then right after that in cout, notice what I do. I say cout less than D1 equals D1. Okay, this right here, if I did not overload the less than operator, it'll tell me, wait, I can't just show the whole object, right? If you try to do something like this in Java, if you're doing Java, what happens when you do something like that in Java? It will actually show you the memory address of the object, right? Okay, well, C++ is probably not even going to do that. It will just error out on you. But this is kind of what we're doing here. So the equivalent of this in Java is when you rewrite the toString method. Okay, so how am I doing this? Right here. And yes, the syntax is not the prettiest in the world. So this is me overloading the less than operator. I'm going to write friend, outstream, and operator, and then after that I put less than. Then I do offstream and output, comma, const distance d, right? That's it. Now the distance d is just an object of the distance type. What's the distance? Well, it's this class, right? So what we're doing is we're sending this d as a parameter into this function or method or whatever you want to call it that overloads the less than, and in here I have outstream and output. So basically, in other words, what I'm telling it is, as soon as I do less than, show the meter variable of this distance class, right? The meter variable, followed by just the letter m. Okay? And when I run this thing now, it will know what to show. It will show me the actual value that is buried inside this object, followed by a little letter m after it. Make sense? Any questions? So again, I'm trying to show, I'm creating different distances here, right? I'm doing D1, D2, D3, D4. If I'm trying to show the whole object with, with the normal cout, C++ doesn't know how to show the whole object because there might be many things in that object. I might have strings and different numbers. It doesn't know, do you want me to show all of them? Do you want me to show some of these variables that are part of the object? So I go in there and I redefine it and I tell it, okay, basically we're going to cout just the meter variable from that object followed by a little letter m, right? So when I do d1 equals d1, what is this going to show me?
The value of m.
What's exactly that? What's the value of d1?
4.
Correct. Right, so it'll show me d1 is equal to 4 and then the little letter m after that. Okay, so that's overloading the cout or the greater less than operator. Okay, so that's the purpose of these first couts that I have in here. Then after that, I'm doing d4 is equal to d1 plus d2. Okay, so now let's go look at these operators up here. So first of all, I have the equal operator. In order for me to make one object equal to the sum of these two other objects, if I just did d4 is equal to d1, that would just make the one object equal to the other object, right? So basically changing one object is going to change the other object. Kind of how we did with the links.
Yeah.
Remember, you set current or whatever it was equal to some link, and then when you change current next, it also changes the actual link next. But that's not what we're going to do here. I'm telling it, no, we're not going to make the two objects equal to each other. And by the way, I just have more than two objects in here, but I could just say d4 is equal to d1 also. So what it will do with the equal sign is it will just make the meter of the object on the left equal to the meter on the object on the right. Okay, so meter here is the variable for d4. Okay, so in other words, the meter variable for d4 is going to be equal to the meter variable on d1. If I just had a d1 on the left, if I just had d4 is equal to d1, what is d4 going to be equal to? Well, d4 is 4. Yeah, they're both the 4. So I didn't change anything. Good. Okay. Now, but what I'm doing here is that actually in one line, I am telling it to use several operators. So I'm telling it to use the equal operator, and I'm also telling it to use the plus operator. Okay, so the plus operator, I'm overriding right here. Okay, so the equal, the not equal, the equal, less than, and I'll have you override a few other ones, right? You're gonna have to override the greater than or equal probably, right? So I haven't done all of them. That's the reason. But so these basic operators, the less than, greater than, not equal, the assignment operator, right? They're very easy. The syntax for those it's not going to hurt you that bad. But some of these other ones are, especially like the less than operator, you can see the syntax gets pretty ugly. Okay, and that's why I don't like C++ that much, because the syntax is just too much, right? There's easier ways to go about things. But anyway, so how do we do the overload plus operator? Well, I just say distance operator plus, so there's going to be an operator plus which is associated with distance, right? And this thing is going to take a constant distance and d. In other words, we're not going to be changing this object that we're going to send in. Okay, so when I have what I have here is I have dist 0, so I'm making a new variable dist which is 0, and I'm telling it now this variable for dist 0, right, which is 0, so this meter which is equal to 0 is going to be equal to this meter plus d meter. Okay, what is this? And I put a little comment in here. This refers to d1. Okay, the one on the left. Okay, and then the other one, the d meter refers to d2. Okay, in other words, what I'm going to do is I'm going to create a new distance object which is going to be equal to the variable of that distance. New distance object is going to be equal to the sum of these two other distant objects meters, meter variables.
We always set it to 0 so that when you do that at 4.
You do want to make it 0 because remember C++ is not going to make the thing equal to 0 by default, right? And if you don't do the dist 0, then you could have some kind of monster number stored inside dist and then in the meter for this particular object, and then you're going to get the wrong number, okay, for meter. So basically we're creating a new object meter, and I'm telling it, okay, we're going to make this meter here equal to these other 2 meters, which refer to the D1 and D2. D1 is on the left side of the equal, the plus I mean, D2 is on the right side of the equal. I mean D is on the, right, D refers to D2, which is on the right side of the equal. And then we're going to return the dist object, okay? So in other words, when this whole plus thing is done, right, instead of D1 plus D2, we're going to have a whole new object, which is the value of meter for which is equal to the sum of these two D objects. Make sense?
So D4 is going to be 6, is that what you're saying?
That's exactly what I'm saying. So D1 is 4, D2 is 2, so we're going to get a new object which has a meter of 6, and now I'm going to say that D4 is equal to that new object, and because I overrode the equal operator, we're going to make the meter for that one on the left equal to D meter, and then D refers to the one on the right. Does that make sense?
Yeah. So the numbers on the bottom where you're at are going to be now 4236. I mean 4206.
Which ones?
So D1 is 4 still. I mean D1 is 6. I think.
D1 is 4, D2 is 2. When you add the two of them, you get a new object which is going to have a meter variable of equal to 6. Then when you do D4 is equal to that new object, you're going to make the meter variable in D4 equal to the meter variable of that new object.
So basically going to change D4 to the value of 6
Yeah.
by pretty much just adding together D1 and D2.
Right, but you're basically not you have to redefine what the addition in terms of object means. You have to tell it, because it won't know how to add objects, right? It won't know what to do with that. You have to tell it, okay, don't add the whole object, add a specific variable from that object. And the object itself could have multiple variables. I just chose to have just one of them, meter, right? You don't have to add all of them. You just have, you define what you want to add, and that's what you're adding. Okay? So that's the overloading plus operator. And then I have a bunch of other ones in here. D1 plus D2 is equal to D4. Then I show you this here. I show you that D1 is less than D2. D3 is less than D1. So in this next line, D1 is less than D2. I overload the less than operator, right? So it's a bool operator, less than, const distance D. The D refers to the one on the right of the equals, of the less than sign. Right? So I have, which one of these two is my D? D1 and D2, which one is the D? D2. All right? So one more time. So I have D1 and D2, and I have a less than sandwiched in between of them. When I look at my less than operator overloading, which is right here on the top, I'm saying meter, return meter less than D meter, which is just going to be either true or false. Okay? So, if you look at this here, so we're just comparing meter. So this meter refers to the thing on the left of the less than sign. And then D dot meter refers to the meter of the object on the right of the less than sign. It's always that way. Okay? Any questions?
Is that because you made the distance D with the const? Is that why it works that way? Like if you made it anything else, it doesn't have to be specifically.
The const, the purpose, the point of const is so that I cannot change this object D. So I'm just saying that even if for some reason I accidentally said, okay, this one D dot meter is equal to something else, it will give me an error message because I sent it in as a constant, so it's not meant to be changed. Okay? Got it? Any questions?
Why is on the distance I had D on all of them except the top one?
The ampersand.
Yeah, that was-
You know, I'm not sure if it's a typo. It might be a typo that I have. Just type it up, see if it works. I'm thinking it should also be an ampersand D, but it might actually work both ways. Yeah, it might work with ampersand D, it might work without it. The ampersand just refers to it's like passing by reference, right? Passing it. You're basically telling it point to the. It's like a pointer. You're telling it point to the memory address of the thing that you're sending in. Okay. So I'm thinking it probably works both ways. So if here's what it is. I'm thinking that if you say distance this D, you probably don't need to have a constant there because it might not refer to the same memory address. But don't quote me on that. Less than D. Yeah, I would say this. Try it both ways.
Okay.
All right. Try with the ampersand sign. Try without the ampersand sign. See if it works. Okay. And then the other ones, they work pretty much the same way, right? You're comparing the thing on the left with the thing on the right. Returns you either true or false, right? And then the last one, CN D4. So I have to actually overload the operator for CN, or basically for the greater, right? So the syntax is similar to overloading the less than. You say friend is iStream, which is the input stream, ampersand operator, greater, input stream, and ampersand input, comma, distance D. So now what we're going to do is when we're going to do input, it's basically like saying CN. We're going to do a CN, and we're going to store whatever we do inside my D.meter, or the variable meter inside the D object. And the D object refers to D4 in this particular case.
Why is it friend? I don't know. Is that just?
It's just the syntax of the language. Yeah, they could have called it a cat or a dog. You know, it's just that's what I'm saying. It's not. This is the reason. Now you're getting into the reason why. You know, can this be done in another way? Yeah, you don't need to overload an operator. You can basically have a method inside of the object, and all you have to do is you have to send the one object inside of another object, similar to what we did with like swapping values.
That's what I was thinking.
Yeah, you could do that. You could do that. It's very easily done, and the syntax is. I mean, seriously, do I expect you to remember this syntax? No, not at all.
I might because it's so young.
Yeah, I mean, it's a good thing to know. You should have it in your like toolbox of things that you know how to do with C++, because you might get a job interview and they'll tell you, okay, we'll overload an operator. Well,
Right.
better have this ready somewhere so you can reference it, you know, and then get it going. But
hard drive with all these things in this class and say I got.
what's that?
Just have a hard drive with like all the notes of everything right here from this class.
Well, you're not every single thing, but some of these things, he's just like, why would you remember this? I mean, am I going to remember this syntax? No, it's not. Yeah, friend, iStream. So you need to know friend, you need to know iStream, you need to know that you need to use ampersand operator. Okay, the operator itself kind of makes sense. It's going to be greater than, but then you have to remember that, okay, now we're going to do the iStream again, ampersand input. Input's going to be referring to basically like the CN. Then you have to do comma distance D. No, it's not.
Is input its own like keyword?
Input is a variable of, so question is input its own keyword? No. Input is just a variable that I made up, which is of the iStream type. So it's basically like saying CN. Okay? I probably could call it CN, but it's going to give me an error because CN is actually a reserved word. CN would make more sense. Yeah, but since CN is a reserved word, we don't get to use it. Okay, welcome to C++. So now you know how to overload operators. This is, it is important. People will most likely want you to do this because if you write a C++ program, it does make it a little easier for you to, have redefine these different operators if you're working with your own custom-made objects. Okay? For me, it really doesn't make a whole lot of a difference, but, it's a good thing to know. It's part of the language. There's multiple ways to do this. We can do it in different ways, but let's leave it there. Okay? Any questions? So what you have to do is you're going to type up all of the above stuff, get it to work, and then you're going to overload these different operators. You're going to overload the greater than, less than or equal, greater than or equal. You're going to overload the asterisk, the multiplication, the forward slash, the division, and the subtraction, right? And I give you examples for all of these, right? So the asterisk, the division, the subtraction, you're going to follow how I did it with this one right here, with the plus, right? So distance, operator, asterisk, const, distance, %d, and then pretty much all the same stuff applies. At the bottom, you just change this thing to, instead of a plus, to a multiplication, and you overload the asterisk. Same way with the subtraction, same way with the forward slash, the division, okay? For the greater than, less than or equal, greater than or equal, what you're going to do is you're going to be using these examples right here. Oops, sorry, not that one. The ones on top. Okay? These are the easy ones. Got it? Questions? We're all good? Okay. So that's overloading operator. We got that out of the way. Oh, and then make sure you test it, right? So here's me testing all these different operators. And if you really do get stuck at some point, look a couple weeks down. You're going to see the solution. I've posted it. All right? So you can double check your actual work that way. Makes it easier. So overloading operators, done. Now let's go and talk about circular lists. Let's see what I have in this lecture here. Oh, more pictures of overloading operators with some drawings and stuff. Basically what I explained to you. Which one refers to this, which one refers to the other one, right? So there you go. Any questions on this one? That's what I was talking about. I should have started with that. Okay. So, all right. So that's that. Now, let's look at circular lists. Okay, and circular lists are fun, if I say so myself. Okay, so circular lists are really going to teach you about lists, right? You're gonna master the linked lists after this one. And if you haven't, we're gonna do another one next week. We're gonna have a double link, double-ended priority queue implemented with a linked list. Right? So you know what a priority queue is? It's like an array where you insert values in order. Well, we can do the same thing with a linked lists. In fact, I might have even had some examples of how you insert an order. So we're going to do that. But let's look at a circular list. Okay, so first of all, what is a circular list? This picture is actually kind of doesn't really do it justice. There is no first. All right, so let me see if I can. Let me look at my 27 class to show you. I think I have a better picture there. Circular list. There you go. That's what we're talking about. So this is a circular list. There's no first, okay? The first that we used to have is just called current, right? And current doesn't have to point to the first one. It could point to any of these other ones, right? So there's no place where this list starts. It's just this, it's a circle, right? This one here links to the next one, which links to the next one, which links to the next one, and then the last one, instead of going to null, goes back and links to the first one. Okay, so the only thing that, huh?
Does it go back to the current one, or does it go to?
Goes to the first one, and the current one can be any one of these.
Oh, I see.
All right, huh?
Well, the current one is the first one.
Well, in this particular case.
Technically starting on any.
Right, but I can grab the current and I can tell it, okay, current is equal to current.next, and then it's going to be this one. And if I said current is equal to current.next, then it will be this one. So there's no concept of first. It's just this the current can go around in the circular list. So you might ask yourself, well, how am I going to know like when to stop? Remember in the regular list that we did, we started first. And we keep going and going and going, and when you get to the null, you're done. So how are we going to do it here?
You say what's the sequence of the
Well, the current is the one that's going to move around. So I guess you could say that you can keep track of like keep track of where current started, maybe make some object equal to that one, to that initial link, and then make current keep moving down until you get current to be equal to that object again, right? Or what you can do is you can just have some variables in there. Let's say you're going to have a variable numLinks, which is part of your circular list class. And now you know how many links you have in the circular list, right? So in this case, we have 4 links. And when you set up a loop, you just make some kind of a count variable. Count equals 0 initially. Count plus plus every time you move through a link. When count becomes equal to the number of links, you went through the circular list one time. Make sense? That's it. All right, so it might take some time for you to wrap your mind around this, as far as the actual implementation goes. But it will pretty much work the same way as the other one, except you just don't have a first. You don't start at the first, you don't end at null. What you're going to be using is you're going to be using the num links, and you're going to be counting how many times you go through how many links you go through in order to determine when to stop going. Okay, so let me go back to this. All right, so let's see what I have at circular list. Okay, so let's have a look at this thing. So I have, this is my link class now. I don't have first. Well, actually, I never had first in the link class. I just have next, just like before. I have a data. I have a constructor to make that data equal to something, and I'm saying that initially, the next of every one of these links is equal to null. So unless I, connect the link to another link, it's null, right? If you have a single link, you would want technically that link to itself, right? So, but we'll look at that in a second. And a way to show the link, right? So let's have a look at this. So what I do is I create a circular list class, which is going to have a link, a variable current of the link type. This was called first before, right? And like I said, I should also have some kind of a variable to keep track of how many links I have. Remember, my lists can expand and contract as I want them to, so I can start with a 0 and I can go to whatever I want, basically until I run out of memory. I can look at the current, right? I can look at the current data, which is basically look at the data of any one of these links. I can look at how many links I have. And this is how I'm going to display the whole list, the whole circular list, right? So what I'm going to do is I'm going to have some kind of a variable count links equals 0, while my count links is less than the number of links, count links plus plus, and then you just show every link. Easy enough. And then current just goes to next every time. Current is equal to current next. Okay? I guess I'm not giving you a whole lot more than that. So let's see what else do I want to tell you. So here's some of the things that I want you to do. So in fact, let me go look at my 27 class where I went and I drew a bunch of pictures for this stuff. All right, so you can see how that works. And the syntax, it might be slightly different, right? But it's very similar, right? So now you're gonna get to see some Java. I had that thing. Okay, so just to get an idea, it's pretty much the same thing, right? You have a class link, it has a data, it has a link next, right? Except Java doesn't use pointers. Okay, but it's the same idea, right? It is going to work the same way. Just the syntax is slightly different. I'm going to redraw some pictures for the C++ class also. I'm going to have to. And by the way, it will be very hard for you to do this without drawing pictures, as you already found out, right? If you thought that you needed to draw pictures for the regular linked list, you're really going to have to draw some pictures on this. And then here's what I did. So, yeah, I don't give you the main in here, do I? That kind of sucks. Okay, so anyway, here's how it goes. So you make a new list, right? So basically this is like saying circ list, the list, parentheses in C++. All right, so this is how you make a new object in Java. So this is my list. What is the list? Well, the list is of this class type, circular list, which has a link for current and counting how many links I have. Okay, so this is the count here is the number of links. Okay, so when I make a new circular list, this is my constructor. When I make a new circular list, I'm setting the number of links equal to 0, and I'm saying the current is equal to no. So when I make my new variable the list, I'm basically saying this is going to be a circular list type of object, which is called the list, and it has a count of equal to 0 and current is equal to no. Okay, so that's the main. By the way, this is the main in Java, public static void main string args. Right? It's a little longer type, but it's actually the syntax in Java is simplified. Okay, then I'm going to do the list dot insert. Syntax for this is the same as in C++. We're inserting the value 10. Okay, how are we going to do this? Well, look at the insert. So we have a link, new link is equal to new link data. So what's the syntax in C++ for this? You would say link, new link, parentheses, new data. Make sense? Here, let me type it.
Write it up right now.
Let me, no, I'm going to write the whole thing. So let me show you. So basically the syntax for this, all right, the C++ syntax for this is link, new link, and new data. Right? That's my C++ syntax for this. So all I'm doing is I'm saying, okay, we're going to create, where's my link? We're going to create a new link. This is my constructor, right? And we're going to make that equal to new data. The data for the link is equal to new data, and then the next for that link is equal to no, initially. Okay? So if you look at this thing here, right here in here, all right? So I'm saying new link is equal to 10, right? This is my link object, which is called new link. I'm labeling it as L1 so we know which one's what. The data of this thing is going to be equal to 10. And initially, next is equal to no, because that's what we said in the constructor for this link, right? Next is equal to no here in the constructor for the link. So as soon as I make a new link, which is this line here, which is, again, this right here. Actually, the syntax for this, link, new link, this line here. In C++, this line will be just link, new link, 10. Okay? Make sense? Got it? Okay. So I'm making a new link with a value of 10, which makes this link here, which has a 10, and then next of that is equal to null initially. Okay? Then I have an if. If my count is equal to 0, right? I'm saying current is equal to the new link, right? So as soon as I say that, now both of these are equal, right? So I have a new object current, which is exactly the same as this other link. So they're both 10. They both have a next of null. And if I change one of them, I'm also changing the other one. The next step that I do is I say current.next is equal to current. Okay? So what does that mean? Because both of these are equal, right? If I say current.next is equal to current, it's basically telling it to point to itself. So what I'm doing is I'm telling it, well, current, or initially, right here I said current is equal to the link 1. When I say current.next is equal to current, well, I'm saying that current.next is equal to link 1. In other words, link 1 links to itself. And current is exactly the same as link 1. So this is the first link. Got it?
Something pointing to itself, does that create memory problems? Or
No.
That's just when you're creating, what is it, when you have to delete stuff?
No, it doesn't create any issues for this. Yeah, there's not going to be any memory issues when you have an object having a next point to itself. Because
As long as you're
it's just, I really don't, honestly, if I have a single link, I don't really have to have it linked to itself, but since we're saying it's a circular list, let's kind of keep it consistent so it links to itself, all right? Even though
So right now you just have
one link. There's just one link, like you're seeing here, right? I only have one link, and my current is equal to that link, and then they're both equal to 10, and their next field is both equal to L1. So they're both same exact thing, okay? And again, the magic here is that since both of these objects are equal, current is equal to new link, changing one changes both of them, right? So that's that. The next thing is, if I have in here, so this is my insert. So we just covered this part right here. Okay? Then the next one is else. So if I don't have if I didn't have no links, then I must have at least one or more links, right? So what happens in that case? And by the way, and at the end of this whole thing, every time you insert, count plus plus. So the number of links increased by 1. So as soon as I insert my link, my circular list object now has a count of 1, and current, which used to be no, is now equal to L1. Make sense? Okay, so that's after I inserted this one. Now, we're going to insert another one. So the list insert 20. So this time, we're going to go into the else part of this insert function. Okay? So the else is right here. And by the way, we have a link, new link is equal to new link, right? So that's basically link, parenthesis, link, new link, parentheses, the value of whatever I'm doing. And I am basically creating a link, right? This is my new link, which is going to have a data of 20. Next of that thing is going to be equal to no, right? It starts there. Then the next thing is, in the else, I say new link.next is equal to current.next. What's current.next? It's up here. So I'm just saying this new link next is now equal to L1. That's all I did, right? So I changed the null to L1. The next thing that I'm going to do is I'm going to say current.next is equal to the new link. Well, the new link is the L2, right? So current.next, which was this up here, is now updated to L2. So I guess if you look at it this way, where's my current? So current was equal to my first link initially, right? They're both exactly the same object, basically. So if I say current.next is equal to new link, which is 2, I'm effectively changing the next field for my link 1. So you can see that both of these now are changed to L2. Does that make sense? So now, and then from before, remember that I established the relationship that the new link is going to be equal to L1. So this new link that I inserted it points to this L1. So L2 points to L1. And then L1 in turn points to L2. And then current is just equal to one of them. Make sense? Okay. And again, you should do exactly what I did in here. Write out the code, draw some picture. Otherwise, you're not going to be able to keep track of this stuff in your head. There's just no way. Okay? And if you want to come over to my office and I'll draw you some pictures, I'll be happy to do that. In fact, I got to redraw this stuff for the C++ class. Okay, so now let's go to the next one. We're going to insert more links, right? So we inserted 2 links. This is what it looks like, right? You have a link 2, which points to link 1. Link 1 points to link 2. And then current was basically equal to one of them, right? Well, let's just say it's equal to the link 1. And I'll move it down one more in a second so that you can see how that works. Okay? So, and then as soon as I insert this link, right, my circular list object, which is the list, the count of that is 2, because I inserted 2 links. Current is still equal to L1, right? I haven't moved current. Current is still pointing to that original link that I inserted. Now what we're going to do is we're going to insert a new link, 30, right? Same deal. I make a new link which has a data of 30. The next field in that initially is equal to no. I'm repeating the same thing that I did before. New link.next, which is new link is L3.next is equal to current.next. What is current.next from before? Right here, L2. So all I'm saying is this new link that I created now has a next field of equal to L2. Right? So now it's 30 and L2. The next thing that I do is I say current.next is equal to new link. So this is, where did I have it? Yeah. So changing current, since current points to link 1, right, also changes link 1. And I'm saying current.next is equal to new link. My new link is L3. So now link 1 has a next field of L3. And my current also has a next field of L3. So what I do is I'm always inserting that new link. Whichever link that I'm inserting is being inserted after the link to which current points. right? So this is L1, this is L3, this is L2, and we already established the relationship of L3 with L2, right? So L3 points to L2 here, L1 points to L3 here, and then when this is all done, we're going to do a little count plus plus. Where is that? Count plus plus right here, right? For the insert function. And that will make my circlist object have a count of 3. Current is still L1. We still haven't moved current at all, right? So far so good? Okay. So that's that piece. Now, let's suppose, because you might think, well, hold on, that's always pointing at the first object, and I thought that maybe there's no first, and how is it going to work if the current doesn't point to the thing that's all the way to the left, or whatever you want to call it? Well, let's move it. So this is the next scenario. Suppose that we moved current one link down, right? Or in other words, I just said current is equal to current next. Okay? So what we're going to do is, it looks like this. Right? So from before I had L1 points to L3, L3 points to L2, L2 circles back and points to L1, but now I have moved my current to be equal to this here. Okay? So in other words, these are exactly the same, and this has a data of 30, and then it has a next of L2. Okay? That's a 2. And then we're going to insert another link. So now we're going to insert the 4. Link insert 40. So where do you think that one's going to go? Before we look at it.
To the next of current.
It's going to be to the right of current, yes. Okay? So the next link, link 4, is going to be to the right of L3. So when it's all said and done, we're going to have an L1, L3, L4, L2. And then L2 goes back to the L1. Okay? So here we go. We make a new link, just like before. Alright, this is my link 40, next field is equal to null, new link next is equal to current next. Alright, and so current next is L2 from before, and that's why it's important for you to write it out every step as you're going through this code. I know it might look tedious, look at it, it took me 3 pages to get to this point, right? But it helps, because I know what the value of next in L1 is, in current. So now I know that the new field next is equal to L2. So that's my new link. L4, it has a field of next L2. I say current.next is equal to new link. So now I'm changing this value here, L2, to be equal to link 4. Okay? And then I do count plus plus, increases the number of links. And what you end up with is you have the L1, L3, L4, L2, and then the current is fixed to this one. Make sense? So that's inserting a link in a circular list. And when we're done with this now, count is 4, and we have changed current. Current moves down to L3. Got it? Okay? So that is inserting. So that's basically insert after value found, right? So in your case, you have to look for a specific value, right? No, this is the new value. You're looking for a specific value in your list, right? And does not insert if the value to find is not found. So if you're looking for a value where you want to insert after. If you can't find it, don't insert. Okay? If there are no links, make current equal to the new link. Okay. Now let's look at these other ones that I have. I'm going to look at the Java one again. So let's look at find. Right? So that's one of them that you have to create. So this is the find, right? The find is basically you have some kind of a counter variable. Start it at 0, tell it to go on while the I is less than count, which is the number of links. Tell it to look for specific data, right? If current.next I data is equal to key. So the reason what I'm doing is I'm telling it to look at the link down from current. So I'm not looking at the data of current, I'm looking at the data of the link down from current. And the reason for this is because this find, you will be able to use this find when you're deleting a link. Because this is a single link list It only points in one direction. If you're trying to delete current, you actually have to connect the link before the current with the link after the current. Okay? We'll look at the delete in a second, all right? So let's look at the find first of all. So the find works like this. We're looking at the data of the link after the current, and if we find it, we're going to return the link after the current, which is the one that has the data. Easy enough?
IData is a function. Oh no, it's a check.
IData is just the data that's part of the link, right? Yeah, the IData is, let's go back to this. IData is basically this right here. It's data, right? I kind of shouldn't have called it data, but yeah, IData refers to integer data, which is basically this field right here in the link.
So you can syntax it like that with the dot, like current dot next dot IData.
Yeah.
Is while it's basically it's like a
Yeah.
if.
Yeah, yeah. So if I find the link, if the link after my current has the data that I'm looking for, right? I'm looking for a data that matches key. Key is just some kind of an integer. So if I find a match, one down from my current, then I return the one down from my current. Otherwise, I tell it current, go to the next one, and I increase my I++. If I never return, if I never hit this return here, that means I didn't find the data, which means I'm going to return no. So this function or method here refers to, is going to return a link, right? If I find the link, I return the link. If I don't find the link, I return no. Easy enough? If I is no longer less than count, you end the loop, you return no because you didn't find it. Okay? And how does that work? I have some picture in there. So I have a bunch of links in there. I went crazy. I had 6 links now. All right, so these are my links. Let's say I am looking for, did I say what I'm looking for? It would be nice if I did. So, oh no, looking for key 30, right? So let's say I'm looking for key 30, all right? And this is the arrangement that I have, and my current has been set to be equal to this link right here. So this is my initial, okay? So I'm going to look at is my current next data equal to the key. In other words, is this link here, is L4 equal to 30? No, right? So then if that's not true, then I tell it current is equal to current next. Now current moves one down, so now current is equal to this. So current is this, data is 40, next is equal to L3. Then I'm going to go back and I'm going to say, okay, well, is my current dot next dot data equal to the key? In other words, is L3 equal to 30? Well, yes, it is. And if that's the case, I'm going to return current dot next, which is my link down from current. Got it? That's why I draw the pictures. I can only imagine how like all this information is just going from one ear and exiting from the other. Okay, that's how it will work for me. I'm not an audio learner. If you just talk to me the way I'm talking to you right now without a picture, it's a waste of time. But there you go. We have a picture. So this is finding the link. Okay. Now let's look at how you're going to delete a link. I'm going to close this too. So let's look at the delete a link. All right. So we're going to have in here I have a switch with count, right? Remember, count is the number of links. I don't have to have a switch. I could have an if. If count equals 0, that's my case 0. If count is equal to 1, that's my case 1. And so it's basically I could have an if count is equal to 0, this one. Else if count is equal to 1, that's this one. And then else, that's the default, right? That's the syntax of how you would write this using a switch statement. Okay? And the reason I'm using this syntax is because that's the syntax that LaForce textbook, the one with the C++, uses. So he uses a switch. I'm sticking with the switch. Maybe I'll rewrite it for this class. By the way, LaForce, whoever wrote the book for the Java class, wrote the book for the C++ class. One is a C++ syntax, the other one is a Java syntax. And I actually use both books to create these lectures. So now you know. Anyway, so what are we going to do? We're trying to delete a link, okay? What we're going to do is case 0. There's no links to delete, right? Well, let's have a look at what I have. So first of all, remember, if I have no links, that means that this object right here of the circ list type, which is called the list, has a count of 0. And my current is equal to no, right? So when I get to case 0, I'm saying temp link is equal to current. Well, current is no. And then I'm saying return temp link. So if there's nothing to delete, return no. Right? Easy enough? Okay. The other case is if I have one link. Right? If I have only one link, then I will be deleting the current. Okay? And by the way, there's one extra little step in here for actually deleting links in in C++. You have to delete the link. Okay? So that part is not shown here. But if you really want to see the solution, just go 2 weeks down. You're going to see how I delete the current link. In Java, you don't have to delete anything. I mean, you basically just tell it, okay, this link that I'm deleting is not being referred to by any other object. And if you have something that's just floating around in memory, Java will know to automatically just wipe it out at some point. If you don't delete the links in C++, your program is going to be sucking up the memory for every link that you used. So you have to actually delete the links with a keyword, delete this link. If you don't do that, you're creating a memory leak. Remember what that was?
That's what I was, yeah.
If you don't actually delete the links, you're going to have a whole bunch of links that are taking up space that are reserved for this particular program. If I have a whole bunch of them and I keep creating more and more links, that's the, and eventually I'm going to run out of memory, things are going to not run. I'm going to end up, the operating system is probably going to kill the program.
It'll crash. It won't crash. It will crash.
Will crash, yeah. Okay. So, looking at this, so this is the case when you have only one link, right? So what I'm going to do is, basically I have link 1, which is equal to 10, next is equal to L1, and that refers to that early example where we're inserting, right? That's the picture that I'm looking at. And what I'm doing is, I'm saying temp link is equal to current. In other words, all these are equal. Right? So whether I say temp link or I say current or I say L1, it's all the same thing, right? Then I say current is equal to no, and now current is basically set to whatever it was originally. Okay? But if I really wanted to delete this link here, there's an additional step in C++ that you have to say basically delete this link, and you're gonna, then you wipe it out and it's no longer, memory leak. Okay? When it's all done, you do count minus minus. So this is what it looks like. Initially you had a count is equal to 1, current is equal to L1. Then in this step here, count is still equal to 1, current is equal to no. The next one, the final step, when I say count minus minus, count is equal to 0 and current is equal to no, which is the original case that I had right here when I had no links. Make sense? Okay. Now let's look at deleting a link after. Okay, so this is my original case. This is what we're starting with. I have count is equal to 4, current is equal to L3, and this is my the list object of the circ list type. Okay, and we're going to this final case right here, the default. Okay, so we're going to say temp link is equal to current next is equal to temp link. And then, by the way, this temp link is what you're going to be deleting in your C++ code, right? So that's the link that you want to delete. Okay. So we go there, and so temp link is equal to current next, right? So this is my temp link, right? Temp link is equal to the next link after my current. Then I say current next is equal to temp link next. Okay, so in other words, this field right here, the next, which is equal to L4, is now equal to L2. Okay, and what happens is, this is the kind of thing that happens. So you have an L1, L3. This is the current. This is the link, which is the temp link. I just told this thing, connect yourself instead of to L4 that it used to be before, right? Now it's pointing to L2. This old link that I had in here, it's just floating around, still there, right? But what I'm going to do is I'm going to delete this thing. And then I just do a count minus minus. In Java, you don't have to worry about actually deleting this link. Java will take care of business. Okay? Which is why, if you have a chance, take my Java data structures class. It will be a lot more fun to do, especially after you've done this. Okay? Syntax is nowhere near as ugly as C++, but it's very similar still. Okay? And then you're returning the link that you're going to delete. And at the end, what happens is my current is still equal to L3, what it used to be, and my count is equal to 3. Okay? So that's how you delete links. You already know how to insert. And what you have to do is, so search, insert after value found, delete link, and display the whole list. Okay? If you get stuck on this, if you don't know how to do it, go look at it in a couple weeks down from today, and you're going to see the solution for that whole thing. Any questions? We're good? Okay. So try to do this. Again, draw the pictures. If you don't draw the pictures, you're not going to get it. If you just go in there and look at the solution and you copy it and you paste it, you're doing yourself a disservice. You really regret it one day, very soon. Okay, especially if you're a computer science major and if you're going to be transferring, you really need to understand data structures, because you're probably going to be given some crazy things to do with data structures. Okay? All right. So, with that being said, that's pretty much all I want to tell you today, but we got to do one more thing. So I'm just going to stop here with the thing, and I'm going to upload you the video.